Hello everyone, my name is Ekin Bircan Boşdurmaz and I'm a junior student in Electrical and Electronics Engineering Department and also Physics in Bilkent University. Today I'm going to present you my Physics 420 Nanoscience and Nanotechnology one-term project, Metal Enhanced Luminescence. Let's start with an introduction. The theoretical basis of this project depends on the band theory of the solids that determines categorizes the materials into three parts as conductors, insulators, and semiconductors. There is a difference in these energy bands, which is called E gap or EG, which is the band gap energy. Also, there is a slight blue region that you can see in this semiconductor graph that actually points out that in the electrons in the semiconductor of the valence band of the semiconductors can jump over the conduction band and the valence band if you provide the required energy of Eg. The semiconductors are the perfect materials for manipulations in their band structures, so that we can manipulate their band structures for our applications in physics or electronics or nanophotonics. In this project, we are mainly focusing on the nanophotonics applications with the metal nanoparticles. The changes in the band structures are resulting in different emission wavelengths, or in the layman's term, different colors of. If we can calculate the wavelength of the photon according to the using that EF minus EE, and final energy minus initial energy, the final energy minus E initial energy, that we can just calculating the excitation over there or there, to find out the wavelength of the emitted photon, since h is just Planck's constant and c is the speed of light. We also see that in the semiconductor nanocrystals, electrons are quantum confined in one region. For example, in the bulk material, we have a continuous density of states, and 2D material, we have a step-like structure. And if we go to the lower dimensions, we start to see a delta function potential like this one. In this project, we actually focusing on the quantum dots and the luminescence enhancement of these quantum dots with gold and silver nanoparticles. They are different wavelengths of different wavelengths of emissions from semiconductor nanocrystals due to their composition and sizes. They are actually called zero-dimensional since they are so small, around 1 or 10 nanometer range. Their properties are really tunable. Like you are actually tuning the wavelength of these emission, also the efficiency of these emission with you changing their size. They can tightly confine the electrons or electron holes or just holes that we call excitons in our study. Also, they have discrete electron states like in the previous slide. There are actually different type of topologies for synthesizing the semiconductor nanocrystals. And we use different kind of methods like hot injection, self-assembly, or atomic layer deposition techniques. For example, you see that just the core structure of quantum dot, and you can just alloy the outer layer of them to increase the confinement. As we said before, their emission wavelengths are really highly depending on their size. For example, if you decrease the size, just increasing the band gap energy, and according to our previous formula, you can guess that the wavelength of the emitted photon is like smaller, so that these photons are more energetic than these other ones. For these kind of metal nanoparticles, we can apply them onto the LED and solar harvesting applications, as well as nanobiotechnology applications. For example, in two studies, one of them is the McGill University case, gold nanoparticles. They use gold nanoparticles to detect the DNA hybridization in also a university that I don't remember its name now. They are used gold nanoparticles and metal enhanced luminescence to analyze the solutions for detecting DNA hybridization again. In this study, I used various kind of references, for example, our lecture notes and also our course books. But I want to suggest this book for beginners for this field and curious people for this field. Also, I'm actually using this. I'm suggesting this book for. Also, in conclusion, we reached that the metal enhanced luminescence is a promising way to accelerate the development in the field of nanophotonics. Thank you for listening.